Dear students, now we solve question number 17 from the question series of IIT JAM 2024 mathematics question paper. This question is given from linear algebra. So the question is, let P11x be the vector space of polynomials in the real variable x with real coefficients and having degree at most 11 together with the zero polynomial. Let E is equal to s0x s1x dot 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 s11x and f is equal to r0x r1x dot 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 up to r11x be subsets of P11x having 12 elements each and satisfying s0 of 3 is equal to s1 of 3 is equal to up to s11 3 is equal to 0 and r0 of 4 is equal to r1 of 4 up to r11 of 4 is equal to 1. Then which one of the following is true? There are four options. Option A, any such E is not necessarily linearly dependent and any such F is not necessarily linearly dependent. Option B, any such E is necessarily linearly dependent but any such F is not necessarily linearly dependent. Option C, any such E is not necessarily linearly dependent but any such F is necessarily linearly dependent. Option D, any such E is necessarily linearly dependent and any such F is necessarily linearly dependent. So let us try to solve this problem. Here the given vector space is P11x. Here the given vector space is P11x is equal to V. Say it is the given vector space and dimension of V is equal to 12 and the given sets are E is equal to s0x s1x up to s11x. It is the given set and another given set F is equal to r0x r1x r11x. The elements of E satisfying s0 of 3 is equal to s1 of 3 is equal to up to s11 of 3 is equal to 0 and the elements of F satisfying r0 of 4 is equal to r1 of 4 is equal to up to r11 of 4 is equal to 1. Now we have to check which sets are linearly dependent. So for the set E, let us consider the relation C0 S0x plus C1 S1x plus up to C11 S11 of x is equal to 0. Now putting x equal to 3, we get C0 S0 of 3 plus C1 S1 of 3 plus up to C11 S11 of 3 is equal to 0. Since S0 of 3 is equal to S1 of 3 up to S11 of 3 is equal to 0, so C0 into 0 plus C1 into 0 plus dot dot plus C11 into 0 is equal to 0. But here C0, C1 up to C11 are not all 0 and satisfying C0 S0 of x plus C1 S1 of x plus dot dot plus C11 S11 of x equal to 0. Therefore, E is linearly dependent. Again, since the elements of the set E is vanish at x equal to 3, then E contains 0 polynomial. So E contains 0 polynomials because if any of them S0, S1 dot 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 S11, any of them is 0 polynomial, then suppose S are x equal to 0 polynomial, then S r of 3 is equal to 0 because it is 0 polynomial. So S3 of r, SR of 3 is equal to 0. Therefore, E contains a 0 polynomial. We know that any set containing 0 element is obviously linearly dependent. Therefore, E is linearly dependent. For the set F, we see that the elements of F are, take the value 1 at x equal to 4. So let us consider the relation d0 of r0x plus d1 r1x plus dot 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 plus d11 r11x is equal to 0, or putting x equal to 4, we get d0 r0 of 4 plus d1 r1 of 4 plus dot dot plus d11 r11 of 4 is equal to 0. Since r04 r14 is equal to r14 is equal to dot dot r11 4 equal to 1, so these are 1. Therefore, d0 plus d1 plus dot 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 plus d11 is equal to 0. If we consider or take C0 of x is equal to x minus 3. C1 of x. C1 of x equal to x minus 3, 1. And C0 of x is equal to 1. So C0 of 4 is equal to 1 because it is constant polynomial. C1 of x equal to x minus 3 to the power 1 because C1 of 4 is equal to 4 minus 3 is equal to 1. C2 of x is equal to x minus 3 whole square. Then dot 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 C11 of x is equal to x minus 3 whole to the power 11. Therefore, the set f will be 1 x minus 3 whole square dot 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 x minus 3 whole to the power 11. This set contains 12 elements and satisfying the condition C0 of 4 equal to 1, C1 of 4 equal to 1, C2 of 4 equal to 1 dot 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 C11 of 4 equal to also 1. And obviously this set is linearly independent, that is, this set is not linearly dependent. Therefore, this set is not linearly dependent. This set is not linearly dependent. Therefore, d0 d1 plus dot 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 d11 equal to 0 implies d0 is equal to d1 is equal to dot 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 d11 equal to 0. So, for this relation, we get all the coefficients are, or all the scalar are 0. Therefore, f is not necessarily linearly dependent. Therefore, in option B, any such E is necessarily linearly dependent, but any such f is not necessarily linearly dependent. We see that the set of elements E is linearly dependent and the set of elements f is not linearly dependent. So option B is true. Thank you.